Hi, my name is Carolyn. It's awesome to be here today talking with you all. I'm really excited. It seems like we have a lot of different disciplines between operations research, industrial engineering, and data science. And yeah, I'm really excited to talk about how decisions are code. Super excited to kind of talk to you all about this. And can I get really quickly just a show of hands of who all is in industrial engineering? Okay, most of you. And then I think that we also have some data science in here. Cool, awesome. Anybody else, operations research? A couple of you as well. Okay, cross-listed maybe? With some of the industrial stuff? Cool. All right. So, as I want to mention, I'm Carolyn. I'm the CEO and co-founder of Nextmv. I also did systems engineering in school, so very similar to the industrial engineering degree here. At Penn, it was cross-listed with electrical, so I did things like simulation and optimization, a lot of decision science type stuff as well. I worked at Lockheed Martin after school, so I actually went to do decision analytics for Lockheed in ballistic missile systems. So I worked on radar systems, B&D programs, so ballistic missile defense programs, combination of like laser weapon systems, stuff like that. Spent most of that time modeling and simulation focused. So we basically ran huge data sets, trying to figure out how the US could have capability against different threat sets. And then I kind of got to a point where I wanted to look at something different. I spent about 6 years there, and after that I left and joined a small delivery startup in Philadelphia called Zoomer. It's actually where I met one of my co-founders, Ryan, who's our CTO. And while I was at Zoomer, I was fascinated to find a startup that was actually doing simulation. Simulation is not super common in the startup world, or it wasn't, especially 5-6 years ago. And I was really excited to find it because I was able to apply basically what I was doing in the ballistic missile space to pizza delivery. And it made a ton of sense. It was still all the same kind of like mathematical processes, random number generation, all that good jazz. And it was really fun to be able to test out the dispatch system, which was really hard to test in like an A/B test fashion because it's so interdependent in the decisions. So after I was at Zoomer, we got picked up by Grubhub, and so Ryan and I spent about 3 years at Grubhub building out all of the automated fulfillment systems behind Grubhub. So everything from forecasting and scheduling to automated dispatch to real-time supply demand management and even ETA generation. So I apologize if you ever had a late order from Grubhub. I was probably somewhat involved, but it was a lot of fun to work on that as well. And so yeah, I've spent a lot of time in analytics, definitely an analytics nerd, and that's my CDO. Domino's had a really sweet GIF that kind of described my previous career, just rockets and pizzas, but I thought it was pretty funny. So who we are at Nextmv, like I mentioned, we scaled a lot of the delivery operations at Grubhub. We had the opportunity to be able to influence like hundreds of millions of deliveries over like our time there and also our time at Nextmv. And I think what's like really interesting about this space in decision science and decision intelligence, operations research, all the things, is that you get to really affect the bottom line of a company. These systems really impact how much money is saved, how much revenue you can possibly generate, and they're really critical to making business decisions and having the operations run. So I think it's really fun to think about how broad decision automation and all that space is, because businesses make critical decisions every day. I think there are a lot of challenges with those decisions though. Some of them are the fact that they're manual, right? So when we add in people to the equation, you don't get as much accountability, right? People have kind of their boots on the ground knowledge of what's going on, and they make decisions maybe myopically or maybe not in context of the network as a whole. You also have the fact that they consume valuable time, whether it's that time automating them or that time actually making the decision. I remember when I first started at Grubhub, I actually walked into a dispatcher's office and got to see what they were looking at on a daily basis. We had automation behind, but we still had operators in a region kind of watching what was going on and making changes to driver assignments or contacting people if things were late. And they were looking at these systems and they just had this giant map and they were trying to like kind of piece together what was going on. It's really hard. When you start to get up to hundreds to thousands of deliveries, those kinds of views start to not make sense or not like really be tangible for a human operator. And then I think one of the other challenges is they can have they don't really have such great ROI if you have a kind of a lack of optimization or lack of automation behind them. And really what you want to get to is a point where operators are picking strategies. So for example, if you're a Grubhub or an Uber or something like that that has kind of a physical presence, you might want to decide to optimize for your driver network being efficiently utilized in one region, maybe that's your more mature region, and in another one you might want to prioritize your new user happiness, right? So if you're like launching Grubhub in a new region, you might want to say like, hey, I want to make sure all my diners have amazing ETA, super fast deliveries, right, and really like kind of boost that engagement from your consumer base. And so you kind of have this situation where your operators are kind of making almost too low-level decisions and repeatable decisions, and you want to level them up to be making those strategic ones. All right, so I like to refer to this as kind of the decision automation lifecycle. So when you're doing software development, you would have kind of a normal process of kind of getting stakeholder feedback, understanding the requirements, scoping, et cetera, et cetera. And during that process, you are thinking about how to kind of automate a certain part of your system, right, or a certain track that you may be kind of hacking around manually to start. And we think about kind of automating decisions on this timeline as well. The challenge is that today, this timeline takes a lot of time. So I was at Lockheed, and we were all the way on 4 in like multi-decision, but those systems had been around for about 20 years. And so we don't want to do that when we're kind of creating these new systems in the world today. And they really start with that process of, hey, first I'm manual, like I may be working in spreadsheets. And this is really, really common. I think it's crazy when I went into the workforce, I was like, oh, like that's not going to be common. People are all building these things in actual software now. That's not true. You actually have operators that are still working on things in spreadsheets and trying to understand what's going on in their company or what's going on for their specific operation, especially like things like scheduling, stuff like that. The second step there is really when you get to, okay, now I have a model, right? Now I can actually define kind of what my input and output structure looks like. I can put something in that black box in the middle that makes that decision. That could be super, super simple. It could be like a threshold-based decision, and that's perfectly fine. I just say simple is better than complex. You at least know what's going on, and you can start to up the complexity over time. Then you start to get to the point in 3, that's kind of upping that complexity. So instead of maybe just a threshold-based model, maybe you have a linear function or a quadratic function or something like that. You start to kind of compare what these different decisions do out in the wild, right? So you kind of get to the point where you need some sort of experiment structure. And that experiment structure for decisions is a little bit harder than it is for something like testing 2 different looks for a website, right? A/B testing is a lot easier than something like decisions because you don't have that interdependence of what's happening. So that's kind of where you start to get into like simulation world is in 3. And then finally, in 4, you get to the part where it's multi-decision. So you have maybe, in the Grubhub example, you had scheduling feeding down into automated dispatch, right? And so however you set up your schedule for the day, dictated how many drivers you have on the road, is impacting how your automated dispatch is working. And so you have to have this emergent behavior. That's kind of where I lived a lot with Lockheed. We were working with our radar system and our weapon system and our comm system, and all of those things kind of came together to give kind of performance for the Aegis weapon system. Does that make sense so far? So decision paradigms, obviously, as you all know, are not new, and they fall under many names. I think this is one of maybe the most confusing things when I went out into the workforce was I branded myself as a systems engineer, but then you look on like Indeed or something and you're trying to look for job recs for systems engineering, you get a wide variety of things. You get IT jobs, you get systems analysts, you get data analysts, you get a lot of different stuff. And so I think this is a real problem, and I thought this Gartner picture was kind of a really good explanation of that, which is all of these things are kind of different ways to think about decision making. You have AI, you have data science, you have kind of all these different parameters. And I really like to kind of like latch onto that decision intelligence there, kind of at the top of that curve. And the reason for that is we have seen kind of over the past 5-10 years that folks are starting to really talk about how to make decisions and how to make decisions at scale. And so this discipline is kind of coming as an umbrella for a lot of more legacy, basically, disciplines like operations research, systems engineering, even applied statistics is kind of getting bucketed up into there. And really the way we think about this is the cloud computing spurred a lot of this. So when I was at Lockheed, we had our own private server rooms. And that's where we were running all of our simulations, was on private clusters. What you have now is, because of things like AWS and Google Cloud and Azure from Microsoft, you have this ability to get really cheap cloud computing quickly at almost every company. And so fundamentally what that's done is it's opened up the aperture for ways to apply different systems with data. And so the first kind of round of that was just digitization, make sure you actually have all the data you need to make decisions. This is kind of event tracking, IoT devices kind of fall in some of this category. You needed signal data at the end of the day. And so then you have the second thing, which had to come along after that, which was, okay, you need to be able to store data, really effectively and efficiently to access it for these types of systems. And then the next wave was, okay, now I need to know what actually is happening in my system. So I have all this event data, right? But where are all my drivers? What is the current state of my world in terms of ETAs? How do I know, if orders are late, stuff like that. So you kind of have this business intelligence wave. Next wave after that has been, data science. Can we predict what's going to happen next, right? Or can we understand what future performance might look like? And now I think we're really in this fifth wave, which is decision intelligence, right? And that's, okay, so we know kind of what's currently happening in our region. We also know what might happen. That's great. Now what the hell do we do about it? And I think that what the hell do we do about it has been this strategy conversation that's been a very human process for a long time. And now what we're seeing is that you have the ability to make this an automated process that you are now managing from almost a portfolio perspective. So you have kind of a portfolio of strategies that you can apply in different scenarios. So I think one of the things that's interesting is, it feels like maybe we're just adding another term to the mix, right, with decision intelligence. And we already have data science, we already have operations research, we already have computer science. So why talk about this in this kind of umbrella term of decision science? And I think one of the reasons is because decisions kind of look like this for optimization today, which I will be very honest with you. When I first started at Grubhub, we tried to get all of our computer science folks, or all of our software developers, in a room and teach them about decision diagram optimization. They quickly opened the book, saw a bunch of matrix math, and were like, yeah, I'm good, right? No thanks. And I think that's a miss, because it's such a powerful technology, right? At the end of the day, optimization and simulation are decision-making technologies. One is hey, let's search for the best possible solution given our input criteria and how we rank them against each other, our objective function. And then on the simulation side, it's testing scenarios. That's how I think about it at the end of the day. And those are two very, very palatable things in the software community that are really well understood, right? Search engines, we all use those all the time. And also on the scenario planning, people do that as well, right, in the software world. So why is it that we haven't really been able to utilize this technology at full scale? And I think a large part of it is this process, which is you had basically translating business rules to linear algebra. You had to have someone familiar with operations research. So everybody in here, right, you had to have one of you in a business, right, in order to understand what was going on and how to translate it into a system that already existed. And that translation is really hard because it ends up being a little bit of whisper down the lane, right? You have your stakeholders talking to your ops researcher is saying, okay, this is how I can structure my problem to look like a vehicle routing problem, or to look like a scheduling problem, or to look like a packing problem. Great. Now what? Now they end up passing that along. They do all the formulation, maybe in Python or something else, and then you end up passing it along to a software developer because your entire tech stack is in Java, right? And so from actually getting those systems into production, that has been a very difficult process, right? Because those things just fundamentally don't match, and you have this whisper down the lane effect and wrapping in microservices. So I think this has been, I like this slide is actually from my co-founder. I really like the, cross your fingers and pray, and hope you did a good job. Why does it look like this? And I think one of the interesting things is that this stuff has been around for a while. I think a lot of the optimization work was done kind of back in the 80s. And computers have been around for a while now, so it made sense to kind of build optimization in this way initially because of the technology that we had available. What's happened in kind of like recent time is that we've realized that optimization is really just a set of strategies. And so we need to kind of reevaluate how we think about those strategies. This is just, I love this graphic. As a systems engineer, I always thought this was hilarious, but each one of these is like how the customer explained it, how the project leader understood it, right? How the analyst designed it, and they're all different. And so the more you have kind of translation layers in the human world, the more those are reflected in your software, right? So the organizational structure or how you build systems is 100% reflected in how they work at the end of the day. And so I think fundamentally we've been asking people to use really confusing technology and to make really tough decisions, and that's a complicated place to be. So what if things didn't look like this? What if we said we didn't need matrices anymore? What if we were able to do something a little bit more flexible? What if we thought about the same principles like relaxation and inference and search, and we applied those to more standard software and data structures? And that's basically what we've been working on at Nextmv, and the decision automation space is exactly that. So instead of thinking about these things in terms of matrix map, we think about them in terms of JSON input and JSON output. These fit into every microservice architecture. They understand data in the same way. We code our systems to look like state machines because that's a pretty common way to think about the world and to think about software. So we say, each time we're kind of building out our decision tree, we're saying, yeah, each layer we're making one decision, meaning I'm a Grubhub and I'm saying I have all these orders to assign to all these drivers. At my root node, I have nothing assigned. And then at my first layer, I'm assigning one thing to each of the drivers or one delivery to each of the drivers. And I start to build out that tree. While yes, we are still searching a space, that space is more tangible, right? It makes more sense to even just an operator to say, oh yeah, I'm building out this directed kind of multi-graph of options. And that is a lot easier to understand and reason about when you're creating a new decision. And then finally, we said like decisions also should have a context. You should be able to run them somewhere. They shouldn't just be kind of like wrapped up in a super legacy software platform and only be able to run in like a Python notebook, for example. When you get out into industry, that's oftentimes not really an acceptable way to productionalize something. It has to go through some sort of CI/CD, configuration management, and be able to be PR reviewed and stuff like that. And so we wanted to be able to have these kind of runners live in different places, so either being able to run on the command line, being able to run through HTTP, or even be able to run in serverless, which is actually not super common today. And so we think about decision automation. So we talked about decision intelligence, and I realize I'm introducing another term here with decision automation, but decision intelligence to me is the discipline around this. So it's kind of what we're all learning across operations research, industrial engineering, right, data science, is understanding kind of how to apply different technologies to decision making. However, you need infrastructure in order to get this stuff into production, right, live in the world and impacting real world systems. And so decision automation to us is that critical infrastructure. We want to be able to create decisions in days and not months. I think this is really hard right now because of that process that I outlined about translating and then getting something into a microservice architecture and all of that. And so we want to get it back down into the normal software lifecycle, which is definitely in days. And the other thing we want to be able to do is it shouldn't just be the folks in here building decisions. If that's true, then we're missing out on a lot of creativity. And if we talk about things like bias, we're missing out on a lot of diversity within our automated systems. And so what we wanted to do is democratize this type of technology to make sure that everybody in the technology space could apply this in any situation that they need. And this fundamentally is different from most of the platforms that are out there because it starts to level the playing field between kind of our operations research community and our software engineering community. And they can both kind of contribute to those same systems at scale. On one side, they were really kind of uncomfortable with applying this type of technology with the software engineering, and on the other side, I would say like our operations research were uncomfortable with the software rigor, right, on the other side. So it kind of balances those two things out. And I think the other things here are integrating using one pipeline. So this is the same as kind of like the CI/CD pipelines for your other software systems. You want to be able to have things like continuous deployment for your decisions, and you want to be able to finally, at the last one, be able to test things. So whether that's simulation, whether that's scenario planning, whether that's unit tests on individual portions of your search tree, you want to understand that things are actually happening the way you expect them to. And then you want to be able to go back and say, okay, I made this decision and 10 orders were late, I want to know why. Could I have had my settings and my algorithm any different that wouldn't have happened? And so you want to kind of start to understand these things at a deeper level. And so we've talked a bit about this as we've gone through here, but we're really focusing on kind of rebooting this decision automation space. And I think a lot of the classic legacy systems weren't really built for the modern tech stack. They weren't cloud enabled for the most part. They definitely were not scaled down to run on things like edge and serverless devices, which is where kind of the industry is heading as a whole for data and computing. And they were really built, again, for those specialized data scientists or operations researchers only. And then I think we're not the only ones doing this. This is actually like a broader trend that we've seen start to pop up. I think the interesting part is that a lot of folks are trying to solve this on what I would call a decision-specific basis. So you have platforms that are out there for like an API for routing optimization, for example, or you have an API for packing, or you have an API for scheduling, or you have an API for price optimization, right? And that's great. Those things are taking what we've just talked about, and they're trying to modernize it, and they're trying to bring it into the software fold as well, but they're really doing it on a very decision-specific basis, and it has that domain context, and it's not necessarily as flexible as most developers might like. And the interesting thing that we've learned is that every operation is a special snowflake. No one is running their operations exactly the same. And I say that from talking to engineers at DoorDash and understanding what we did at Grubhub. Like even though the platform maybe to a consumer looks very similar, no one's kind of considering that data in the same way, and their operations are fundamentally different. So you need to kind of have that flexibility to do customization and understand kind of that same infrastructure across your whole stack. So we have an idea that basically decisions should be these four things. They should be composable. And the reason they should be composable is you should be able to, like I said, unit test individual pieces of your decision-making software. You should be able to test a state transition, for example. That's not really possible in the way that most optimization technology works today. They should also be repeatable. So we are very big on the fact that you should be able to store your input and output and understand how to recreate a decision exactly. This gets back to kind of accountability and traceability. And I think it's also really interesting. I did another talk at Bucknell, and one of the students kind of came up to me after and said, "Hey, like, how do you make sure that these systems aren't biased?" And I think this repeatable part is actually one of the ways that we actually are able to fight bias, because that's a way we can go back and say, okay, what would the decision have looked like if we had a different algorithm kind of providing the solution? And so I think that's actually a really important one. Testable, so models look like other code. You can actually put them, again, in things like CI/CD. You can test them against a set of predicted inputs, or you can test them against a set of historical things. We did this a lot at Lockheed, but it's not something that I've seen done really at scale a lot of other places, where we had a kind of compliance data set, and we had a regression data set, and we were running those things on a daily, if not weekly basis to make sure that our systems were working well. Made sense at Lockheed, right? There's very high stakes in the ballistic missile world, so you wanted to be able to run things all the time. But I think what you're seeing now is that the stakes are getting higher in all of these multi-sided marketplaces. You're potentially going to miss out on millions of dollars, right? Or increase your costs significantly if you don't do good testing. And then finally, scalability. So you should be able to run a decision on your local hardware just the same way you should be able to run your decision in a cloud service. And so you should be able to do that development lifecycle the same way other development lifecycles look for software as well. Has anyone in here done anything with like VRP, like vehicle routing problem solvers? Show of hands. Nobody? Okay. This one, traveling salesman problem, is pretty common, so I thought I'd bring up an example of this. In other contexts, so that all that matrix math and kind of setup that I had on a few slides prior was setting up for this. So we can kind of see the difference between those two things. This is what kind of solving a routing problem on our tech stack looks like, which is just adding things that are very human readable, right? I'm adding a set of stops, a set of vehicles. I'm adding where those routes are going to start, where they're going to end, and I'm also adding some constraints. And so this is what we really want decisions to look like. They're composable. You can add in different features. You can add in different constraints. You can change kind of the parameters for your value function, and this is how we kind of think about it. When I talked about repeatability, so I had that JSON input-output structure. They're a little small, but they're trying to get to the sense of, okay, I have all of my metadata about my decision there on the right when I'm talking about my output. I know exactly what version of the software it ran on. I know all the settings down to the search settings. I also know what the state output is that I got for that particular input, and I can track both of those things and understand that configuration better. We talked about testing a bunch, but here's what that looks like in practice. So we actually use our GitHub Actions for our CI/CD. So all of our development is going on in Go, and we work through GitHub. And so when we're putting a new PR in for our solver, let's say, or for our router engine, let's use that example, we would actually run this against a set of inputs and understand what the performance is and get an acceptance test for that. And we can also understand kind of our CPU utilization, which is up in the top right, and also build some unit tests. And then finally, when we talked about that scalability, this is what that might look like. For us, it's a single line code change to go from each one of these runners. That means they can take the same input and apply it across these different contexts as you're deploying in different spaces. So this went pretty technical. If we come back up to the why should you care, this stat is like pretty horrible, and I've quoted it a couple times, but it makes me really sad. That 87% of data science projects or AI projects never make it to production. And I think that's a miss. And I think we collectively, as kind of industrial engineering, systems engineering, ORMs, et cetera, need to look at this and really figure out ways to address it. And that this, the way we built Nextmv is one way, but I think this is a really big problem in order for us to move forward with these automated systems. And there's a lot of kind of discussion not only about that, but about systems thinking. You kind of see a lot of people talking about systems thinking, decision intelligence, and a lot of different terminology there. And actually in the top right is one of our investors who said, there was this big data, and then there was MLAI, and now there's automation. These aren't really separate trends. They're actually just the kind of full continuation of the same trend and realization of it in the market, which is pretty cool. So I've talked a lot about decisions in the abstract, but here are some of the types of decisions that we talk about on a daily basis at Nextmv. So we have a lot of customers that do routing and assignment problems. As I'm sure you all know, COVID made it so that every company became a logistics company and every company became a delivery company. So there's a lot of folks out there that are trying to solve that problem. I think the interesting thing is that having kind of a solver underneath is almost table stakes for those companies, and the way they are orienting their operations on top of those solvers is actually their differentiator. We also have kind of a matching. People are trying to put appropriate products maybe in a subscription box. So I'm a Stitch Fix user, and I really think it's fascinating that they're able to have this limited inventory for a bunch of different shirts and items and things, and they have to actually allocate that across all their subscription boxes. What do they have? They probably have data science models that tell me that the ROI of sending this to me is going to be higher than the ROI of sending it to somebody else. Great, but now I still have that limited inventory, and if I'm tied with someone, how do I decide who gets that item, that sweater that I like, right? And so there's problems like that. There's tons of things in the supply chain space around packing. So if you're packing trucks with packages, or your USPS, and you're trying to deliver things in a reasonable fashion, you need to pack the truck not only for the size and weight considerations, but you also need to pack it in a way that's easy to get those items out. And then there's things like clustering, so understanding how to cluster different geographies or groups of things. This is kind of an interesting one. We actually we were able to build a constraint clustering engine so that you could constrain it with different things, either just the number of items in a cluster or even some other kind of metadata parameters. And then there's even scheduling. Scheduling is a big one, but workforce scheduling, shift planning, kind of understanding. This is a very, very, very big thing in the healthcare space, obviously, with patient planning and stuff like that. And then I think the thing I'm most excited about as CEO of Nextmv is just seeing what people do with this technology. So that create your own bucket is kind of where my interest lies. Over the next couple years, we're going to be working a lot to build a community around this, both for software developers and operations researchers. And that create your own is, I think, what gets me so excited, because you have fundamentally this large group of people that has never had access to this technology, and what creative things are they going to do with it. My co-founder, for example, built a Sudoku solver right on top of this. That has very little, obviously, business impact, but it's kind of fun, right? And you can start to see how you apply these systems in kind of unique and interesting ways. I've asked for a Wordle one. He's still waiting to get back to me on that one. All right.